Welcome to page 5 of 3.2, our last page of this section. Probably a good time for me to just take a breath here and say that this section, probably more than any in the book, confounds some people, and so do not just sit there and not ask questions because you're either embarrassed or you're thinking somebody else will ask my question. Oh, everybody, here's the one I get most often. Nobody else was asking a question. Yeah, there should have been probably 10 people asking the question. Step up, be a leader. You've got some questions to ask. Make sure you're asking them. So when I look at this right here, forget about this for a minute. Let's think about our definition of logarithm. 0 is the exponent that's turning e into 1. That is a logarithm, the way I read it there. 0 is the exponent. 0 is the exponent that is turning e into 1. Now, of course, we could write that as 0 equals ln 1. That's where I think it's probably worth writing the e. So 2.5, that little innocuous word is, 2.5 is the exponent. Oh, the exponent is log that turns the base into the argument. 2.5 is the exponent that turns e into 12.1824 ... Of course, that can be ln 12.1824 ... Now, I'm going to rewrite this as e to the negative 4th. And now we see that negative 4 is the exponent log, in this case ln, is the exponent that turns e. There's a sneaky hidden e. Negative 4 is the exponent that turns e into 0.0183. So this is the exponent, negative 4, that turns e into 0.0183. And 3/4 is the exponent, log base e, might not be a bad idea to write it as log base e, is the exponent that turns e into 2.1170. Guys, I just can't express it strongly enough how important it is that you understand that and don't just say, okay, well, in this case, I take the 3/4 and I put it here, and I take the 2.170 and I put it there. I don't really get what's going on there, but it gets me the right answer. That's not going to work for you long term at all. So go through it, ask questions. Okay, use properties of natural logarithms to rewrite the expression. So in this section, we're just going to be simplifying. So let's take a look. This thing, I'm going to write it as negative log base e of e. You might not need to do that, but log base e of e is a great way to read this. Even better would be ln e, but a terrible way to think about it. This is the exponent that turns e into e. What is the exponent that turns e into e? 1. So we just get negative 1. All right, let's forget about this 7 for right now. This, listen closely to it, and you might need to rewind it and listen to it a few times. This is the exponent that turns e into 0. That's what our definition of log says. See, we got a sneaky base e. This is the exponent that turns e into 0. I wonder what the exponent is that turns e into e to the 0. Oh, of course that's 0. What is the exponent? Did I say e to 0? E to the 1st. Was there a 0? Oh no, there was a 0 in it. That wasn't my 0. Sorry. That 0 was written in here. All of a sudden I thought that was my black line. So what is the exponent that turns e into e to the 0? 0. So this whole thing is just 0. 7 times 0, 0. Watch this one. E raised to the exponent that turns e into 22. Did you hear it? e is being raised to the exponent that would turn e into 22. This guy's whole purpose in life, wandering around in life, oh, I'm an exponent that would turn e into 22. That's my job. If only I could find an e to be an exponent on, I would turn it into 22. E is being raised to the exact exponent that would turn it into 22. This whole thing just equals 22. E is being raised to the exponent that turns e specifically into 22. How about this one? ln e to the negative fourth, or log base e of e to the negative fourth. This is the exponent that turns e into e to the negative fourth. What is the exponent that turns e into e to the negative 4? That's what this thing is. What is the exponent that turns e into e to the negative 4? Well, it's negative 4. Okay, and find the domain, the vertical asymptote, the x-intercept of the graph. So we're going to go ahead and roughly stamp these things. It's going to be a little bit strange here. E, if you recall, we talked about in the last section for our purposes is about 2.7. About. So we have a vertical asymptote that, see, x plus 1 can't be 0. Let's see where I want to put this. X plus 1 can't be 0. So x cannot be negative 1. So there's our vertical asymptote. X equals negative 1. X can be bigger, so everything's going to move to the right. And now I'm going to choose some decent values for this. So log base e. Let's see, I'm going to choose a value for x. I'm going to add 1, and then I'm going to take log base e of that. Now, values that I want, I'm going to use this whole 2.7. It's just going to give us some approximations. So, values that I want to put into e would be like 1 on e, 1 on about 2.7. Just 1. 2.7. 2.7 squared. So this is 2.7 to the negative first, to the 0th, to the first, to the second. What's the exponent that turns e into 1 on e? E and 1 on e is negative 1. E into 1 is 0. E into e, 1. And e into e to the second, 2. And then I want to subtract 1 from this. So, well, all right, I guess I'm going to subtract 2.7 on 2.7. That's negative 1.7 on 1. Not the most convenient, and I'm not going to have you rubber stamping e graphs, but we're going through this so you've seen it. Subtract 1, I get 0. See, we're going backwards here. To get from here to here, we add 1. To get from here to here, we subtract 1. At about 1.7, our graph's up 1. And let's see, on 2.7-ish squared, and it's not exact, 2.7 squared is about 7.3. So at about 7.3, we're up 2. So here we go. 1, 2, 3, 4, 5, 6, 7, 8, up 2. So at negative 1.7 on, oh, that should be on 2.7, excuse me, on 2.7. So getting close to negative 1. At negative 1, we're down 1, somewhere in here. At 0, we're exactly 0, though. That's kind of nice. I've got to go out to 1.7 to get up to 1. And I've got to go all the way out to 7.3 to get up to 2. So our graph looks like that. We've got a vertical asymptote let's see, sketch the graph by hand, find the domain, the vertical asymptote. So our domain is x is greater than -1, and our x-intercept is 0. Okay, ln. I'm going to write this as negative x minus 3. I'm going to stamp this thing. So again, if we knew exactly what ln looked like, we could just shift it to the right 3 and flip it upside down. So here's what we've got. I'm going to choose a value for x. I'm going to subtract 3. I'm going to multiply it by -1, and then I'm going to take ln. This is going to take some practice, no doubt, and some questions. Here's the deal. I want to pick values for 3 minus x. I want to pick values that go right here. I want this to be 1 on 2.7. I want it to be 1. I want it to be 2.7. And I want it to be 2.7 squared, which we decided was about 7.3. Because what's the exponent that turns e into 1 on e? -1. E into 1. E into e. E into e squared. I need to get from row B to row C, I'm multiplying by -1. I need to divide by -1. -1 on 2.7. -1. -2.7 and -2.7 squared. And then I need to add 3. Adding 3 to that. Just going to be lazy. 3 plus -1 on 2.7. Math, fraction, really being lazy. 71 at 7.1 on 2.7. 7.1 on 2.7. I need to add 3. When I add 3 to this thing, that one's pretty easy. In fact, you know what? Maybe I just like the 2.6 there. Got a little bit of a mess here. I'm at about 2.6 right here. Okay, when I add 3 to 1, I get 2. When I add 3 to this, I get about 0.3. And when I add 3 to, what was our 2.7 again? 2.7 squared. When I add 3 to 2.7 squared, these are, when I add 3 to that, we get, and that's negative 7.29. So I get 3 minus 7.29. We get negative 4.29. Okay, so there we would have some values that we can go ahead and put on there. We've got a vertical asymptote, though. This is the biggie of, and it looks like our graph is going left as well. Vertical asymptote. Let's ignore that because we're going to go left. Of 1, 2, 3. We've got a point at 2.6, -1. So somewhere right around in there. We've got a point at 2, 0. That's nice. There's our x-intercept. X-intercept is 2. We've got a point at about 0.3 up 1. About 0.3 up 1. And we got another one all the way over at negative 4.29 before we get up to 2. Okay, again, I'm not going to have you do that with E, but if we had to do it by hand, we could. The only thing I'd have you do with this thing by hand would be, I would say, hey, describe the graph of this, and you'd say, well, it looks just like the graph of ln x, except it is to the right 3, down 1. Okay, so I fully expect to be looking at some of these things with you. To be perfectly honest, a little bit easier here then the 192 is kind of a worst case scenario for this type of problem. Maybe you can muddle through 91. I don't feel like I've done a great job explaining that, so let's make certain that we're asking questions. Happy to help with it.